Do you think we are on the track to technological singularity?
I guess it depends on what you mean by on the track. So, um, the first thing I'll say is I don't think that there's a magic moment of singularity. I think that that's a very crude approximation. So, if you imagine that intelligence was a one-dimensional variable, then there might be some day at which, at that point forward, machines were smarter than people. But the reality is, intelligence has many different facets to it. Some of which machines are already far better than people in some of which people are still far better than machines. So, in raw computational power, I think machines probably exceed people, although you could have an argument. But for example, in analyzing positions on a chessboard, there's no question that a computer is better than the average person and even the best person. In doing floating point arithmetic, there's no human being that can compete with a machine. And that's a form of intelligence. It's a form of artificial intelligence to be able to do math. And the symbolic integration of Wolfram's Mathematica far exceeds what most people can do, even with a great deal of training. On the other hand, the ability of an 8-year-old to watch a Pixar movie and understand what's happening far exceeds any machine that we have. So, a child can understand, who's the good guy, who's the bad guy, why are they doing what they're doing? Maybe the child doesn't get every nuance. And the ability of an adult human to watch a complex television show and understand all that's going on there, and when it turns out that the bad guy is actually the good guy and the good guy is the bad guy, and all based on one line of dialogue. There's no machine that comes anywhere near close to that. So that's another facet of intelligence, which is like understanding a story or a conversation or news article. Artificial intelligence is nowhere on that. Fundamentally, current AI is illiterate. It can kind of fake its way through, but it really doesn't understand what it reads. And so the idea that all of those things are going to change on one day, and on that magic day, machines are going to, be quote smarter than people, whatever, it's gross oversimplification. However, for the sake of argument, let's suppose that it was sort of vaguely right. Even then, you'd have this question, which would be like, what do you mean by on a track? So, at a broad level, yes, we're on a track to build machines that are smarter and smarter. We're spending a lot of money on it. We're really trying hard to do the problem. There's progress in some areas, but not others. So, in that very broad sense, yes, we're on a track. It is likely that in 500 years, machines will be much smarter than they are now, and probably they will be in 50 years. Are we on a specific track is a different question. And my answer to that would be no. The specific track that we are on that occupies something like 95% of the resources, including money and people and so forth, are these things called large language models, which are an extension of big data. And my view about those is not that optimistic. So, most of the field is working on them, and there's a lot of short-term benefit to those systems. So, they're very good at making dialogue for a surrealist play where it doesn't really matter what goes on. So you type in anything you want in GPT-3 and you get some kind of response. These systems are astonishing in the breadth of their coverage. You can talk to them about anything, but they're less astonishing in their ability to not be toxic, to tell the truth, to be reliable. And I don't think that we want to build a general intelligence that is unreliable, misinforms people, is potentially dangerous if its requests get set into action. So you have GPT-3 recommending that people commit suicide, for example. We don't want our intelligence to do that. So, if we follow the path that we're on now, first of all, I would say that's dumb. A machine that recommends suicide, except maybe under various narrow circumstances, is not actually what I would call intelligent. The machine is doing that because it doesn't really understand what it's recommending at all. It just, knows you should be positive. People say things and a good answer to almost anything. It sounds good to me. Well, it turns out if what the other person says is I'd like to commit suicide, sounds good to me is not actually a good answer. And, a system that is superficially responding to what you say without understanding, it's not very intelligent. So you have the problem that it's not very intelligent. And you have the problem that lack of intelligence can cause harm, like recommending that people commit suicide. and so forth. Unfortunately, that's the biggest street light that we have right now. I don't know if you know the old joke about the drunk going around in circles looking for his keys, and the cop comes up and says, "Why are you going around in circles looking for keys?" And he says, "Well, that's where the street light is." And the whole field, it has this one massive streetlight, but I don't think the answer happens to be under that streetlight. And what we're doing is investing more and more. If you talk to anybody who invests money for a living, they will say that one of the most important things is diversify, because you never know what's going to happen, right? And so you have to balance your portfolio. So you put some in stocks, you put some in bonds, you maybe keep some in cash at a good interest rate, whatever. But diversification is always considered key in any financial context. And that's not what's happening in AI right now. There is a real distinct lack of diversification. There's not zero. There are a few people kind of working outside the box, but what you get, I think, is an optical illusion where, because the investment in X so far exceeds all of not X, everybody thinks X is doing great. And, it's doing great in a short-term way. I don't think it has the potential to get us where we want to go in the long term. So there's actually a term in the field, which is a local maximum. If you think about climbing the Himalayas, you can get to the top of a peak, but be nowhere near the top. And you put all your efforts into climbing, this little baby peak, when there's a much bigger one you actually want to get off to in the distance. And that's where I think the field is right now. It's at a local maximum. Like, this peak is higher than anything else that's nearby. There's no other available technique that works as well. But we don't want the available techniques if we really want to build trustworthy and reliable AI.
This reminds me of something you said to Hinton in your New Yorker post, where you said that Hinton has built a better ladder, but that doesn't necessarily get you to the moon.
It's right. And I borrowed that from I think it was Hubert Dreyfus many, many years ago. I applied it to deep learning, and I still think it's true. So that quote from my New Yorker piece was 2012. It's 10 years later. And what I projected then was that these systems would have trouble with language, causal reasoning, abstraction, and so forth. You can maybe put in the quote in the show notes or something like that. I think all of those have held true. So yes, there's been enormous progress in the ability to label objects, to do machine translation, but not in machine comprehension. Systems like Siri and Alexa and so forth are still very limited. There's certainly not systems that you can count on to reason. I mean, there's no system where you could sort of introduce the facts about some everyday situation and have any hope of getting the right answer. The best ethical reasoning system that's been built, and one of the very few, is Delphi, which is basically a large language model. And it runs around saying things like, genocide would be okay if everybody was happy with it. It just, it recognizes the words "if everybody be happy." Doesn't understand what genocide is, or that this is actually inconsistent or ironic or whatever. And so, moral reasoning is nowhere. And a healthy field, and I don't think AI is a healthy field right now, would recognize the limitations and go after them. But a large part of the discourse in AI right now is people telling critics such as myself, "Oh no, it's all hunky-dory, and there's no problem here," which is to say, it's not really acknowledging the limits. But there's a lot of people that take every bit of progress to be kind of universal progress, not realizing that even if you make progress on X, you're not necessarily making progress on Y. And DALL-E 2 looks like progress in some ways because it makes these very pretty images, but in other ways it's not progress at all. So fundamentally, actually, since we spoke, I got a little bit of access to DALL-E, and what I told you was, what I conjectured was correct, which is, it's one thing if you want something kind of in general. So you want a picture of a house and a person in front of it. But if you want to be really specific about it, it's not going to work for you. It hasn't really solved the problem of language. There's lots of problems with the linguist or philosopher of language, Gottlob Frege, described as compositionality, understanding a whole in terms of its parts. So if you give a complicated description to DALL-E, it's going to have problems. If you ask for a red cube on top of a blue cube, it might just give you a blue cube on top of a red cube. So it's recognizing some of the parts of what you say, the red cube and the blue cube, maybe some of the time, most of the time, but not always. But it's not recognizing the relationships between them. And this has always been a problem with these kinds of architectures. They're not very good at recognizing relationships. That's not magically going away. We have, I think, maybe 1 billion times amount of data is when I first started looking at these problems or these systems in the 1980s. If you have 1 billion times more data, you can do some magical things, but these basic problems around compositionality, which are absolutely prerequisite for any real intelligence, there's no solution within this approach that is so dominant.
Today, transformer models like GPT-3 or generative models like DALL-E that you mentioned, they are some of the biggest innovations in AI. And yet you say we are very far from actually reaching the kind of AI that we want. So, are we actually any closer to building an artificial brain? Or how do we measure that? Like, do you think the Turing test is a
it depends on what you want. So I'll take the Turing test first. The Turing test is not a very good test, it turns out. It turns out that the whole field of AI has had trouble building benchmarks that really are valid measures of what we want. Fundamentally, what we want to measure of is intelligence. And it turns out that almost every measure, or so far every measure that we have devised, has not really measured what we want it to. So let's take the Turing test, because that's the most famous. The idea is, if you could make a machine that could fool a person into thinking that the machine was a person, then you would have found intelligence. Well, that was a neat idea. It was a reasonable conjecture in 1950, but it turns out it's not a very good test. Why does it turn out to be not a very good test? Well, because humans are gullible, and number one, and number two, you can be evasive. So a real human being should be able to answer a very wide range of questions. If you want to build a system that fools people, you just don't answer some of those questions. So there was a system back around 1970, I think, called Perry, that pretended to be paranoid and did a reasonably good job of fooling people. And then Eugene Gustman was a system that actually kind of won a small version of the contest for a few minutes. And it did this by pretending it didn't speak English. The contest was in English. You were allegedly talking to a 13-year-old boy from Odessa, whose English wasn't perfect. And, 13-year-old boys are kind of smart alecky. And so like it would respond with wisecracks to evade, revealing its limitations. And to the untrained eye, it was fairly convincing. A professional could still recognize limits, because you'd ask it like, is a toaster bigger than a refrigerator? And it might not know the answer, and you'd be like, okay, I know this one's a bot. But if you're not a professional, you don't know to ask questions like that. So it could fool an ordinary human being, but so what? All that tells us is that human beings think that machines that can talk are intelligent, but that just turned out to be untrue. Like Eugene Guzman is not intelligent. It was just this game. The earlier system, Eliza, was like that. He's really not intelligent at all. But because it would occasionally say things like, you mention your boyfriend, and it says, oh, well, tell me more about your family or whatever. And like people would be like, they would be taken in by it. And that's what's happening with GPT-3 is it sometimes says smart things. But for example, it has no long-term conception of what you're talking about. So I played around with it in the character of Socrates and asking questions. And I said to the machine that I was talking to, are you a computer? And it says yes. And then I say, are you a person? And it says yes. Like it doesn't remember from 1 minute to the next what it said. There's no consistency. There's no real intelligence there. It's again an illusion. So then there have been a bunch of other measures. And it turns out that humans aren't that great at making tests. So like if they have multiple choice, maybe answer number 3 is often the right answer, because people just aren't that good at making tests. So the machines pick up on that kind of stuff, and then they wind up, passing the test, but it doesn't mean that they really have the comprehension that we're ultimately after. For now, we're left with a problem, which is that the whole paradigm of studying some big training set in order to work on some benchmark has not proven that fruitful on the deeper questions in AI. And, it's good for getting grants and this kind of stuff. But I think very little of the research is directed at these deeper questions of how you get a system to understand a whole in terms of its parts, or how you build up a representation of an evolving world so that you can act over it. Like people in robotics, for example, know perfectly well that you're not going to succeed in robotics unless you have a clear representational model of the external world. But you look at most of the research that is in AI right now, people are ignoring that question, or they're hoping for the best. They're sort of, if I have more data, maybe this will work a little bit better. Here's an example from a recent paper. The company called Anthropic looked at 3-digit arithmetic problems and different size models that had 1 million parameters, 1 billion parameters, close to 1 trillion parameters. And it got better and better at these 3-digit arithmetic problems, integer arithmetic. So, 322 plus 671. But it was still only at 80% correct when it had almost 1 trillion parameters. This is really inefficient and unreliable. Another recent study showed that which math problems these systems get is strongly predicted by the particulars of the training set. So if 23 times 12 is in the training set, the system is going to do better at that than 23 times 11, which isn't in the training set. Well, you compare that to a microprocessor or pocket calculator, and that's just bizarre. So why are we working with a system that can't just answer an arithmetic problem, right? I mean, my calculator can do that. And so in some ways, this stuff even seems like a step backwards. But try telling the world that the emperor has no clothes, and then people start to attack you, right? So I wrote a paper saying deep learning is hitting a wall, and the field was furious, and they started, making all kinds of cartoons about deep learning is, stepping over the wall and whatever. None of them seem to have read the intellectual content of what I said, which is not that you can't do anything with deep learning, or not even that you shouldn't use deep learning, but that you're going to have to use it in association with other systems because there's these particular weaknesses.
One of the things that you said in your debate with Jan LeCun, where you said that if neural networks have taught us anything, it is that pure empiricism has its limits.
Empiricism is this idea that you would learn everything you need to learn just from an experience with the data in the world. And the opposing position is maybe you need to have some prior knowledge of some things like space and time, the fact that objects are enduring entities that persist for some period of time in the world. So the latter position is what we would associate with Immanuel Kant in the Critique of Pure Reason, with Plato in the dialogue with the cave boy, and also with developmental psychologists like Liz Spelke and linguists like Noam Chomsky and myself. And the empiricism, a lot of British philosophers of a certain period, Hume and Locke and so forth, took a view like that. And I think most people intuitively believe the empiricist view. They believe that if you just experience the world, you eventually work everything out for yourself and so forth. But I think if you look at the data for humans and other animals, we are actually born knowing something about the world. Fortunately, most computer scientists aren't trained in developmental psychology. And they, like Jan LeCun in that debate, referred to Piaget, which is great. Piaget was a wonderful developmental psychologist, but he's been dead for, 30, 40 years. I can't remember exactly. And some of the things that he supported just turned out to be wrong. So, for example, Piaget thought that babies were not born with a sense of objects persisting in time. He did an experiment where you cover a keychain with a blanket and the kid stops reaching for the keychain. But that's because the blanket is interesting. It just wasn't a good study. People have done better studies like Liz Spelke and Renee Bayer-Jean and so forth. And it's clear as young as you can test babies, maybe 3-4 months, they certainly know that objects persist. So you have theoretical arguments that Kant and Chomsky and others have made. And then you have the empirical data, experimental data from Liz Spelke and Renee Bayer-Jean, et cetera. It's very clear that at least humans don't and shouldn't come to the world fully unprepared. But these networks that are so popular largely come unprepared. They don't actually have built-in representations of time, only a marginal representation of space. They have no representation of an object or a persisting object. They have no prior representations of what language should be. And fundamentally, language is about relating sentences that you hear to an understanding of the world. And systems like GPT-3 just fools naive humans into thinking that that's what they're doing. They're not really. And it inevitably shows when you give them a sentence like, or you ask it, is genocide okay? In that sentence, genocide is okay, is something everybody enjoys. And they can't reason their way through that. They can't recognize irony or sarcasm or contradiction or any of that kind of stuff that you would expect of an intelligent being. So yeah, I see these systems as a test of the empiricist hypothesis that you would just learn everything from experience and nothing built in, and is a failure. Like I see them as trying very hard and not succeeding in doing that.
So is that something that is actually possible to teach a machine to think the way that humans do? Be it, if not the empiricist approach, do you think even with the nativism approach, is that something that we can actually do?
Not yet. I think we will be able to. So I don't see any argument in principle why we can't. I think we need to understand how to build in more knowledge. We're not very good at that right now. We're good at certain kinds of knowledge that we can embed in the systems that don't really know how to do others. I don't think that the nativist hypothesis has been shown to be correct so far, though. So one of the things that's pretty clear is that we're going to need multiple systems, none of which are individually perfect, and we're going to have them work together. And we don't have good methodologies for that. We don't really know how to debug complex cognitive systems. We know how to debug ordinary computer programs, but most of them don't have the complexity that I think is required for AI. Programming is hard, and programming at large scale is hard. And we don't know enough about programming systems that think about abstractions and so forth. Like there are some fundamental questions there that I think haven't been answered and are barely even addressed. And then, the machine learning paradigm has its own way of developing. It has its own problems in terms of debugging. So the dominant paradigm is largely uninterpretable. You get an answer out. If it doesn't work, you try something else. But it's not the same thing as like debugging a computer program. You're like, well, what were the values of the registers at this point? And, why does it think that this is a 3 when it should have been a 2 or whatever? And so, on both sides of this continuum, there are problems. And of course, what I've argued for is hybrid models that take some aspects of the classical systems and some of the deep learning systems. Nobody really knows how to do that either. So, there's no question in my mind that right now we don't know how to build AI. I think of us as like alchemists before chemistry arrived. Like, we can see there's something really interesting there. Alchemy was fascinating. But at the time of the original alchemists, like they didn't really have a theory about what they were doing. They were mucking around. And, eventually people figured out like, hey, there's this periodic table. This is really cool. We can do some stuff with this. We don't have that yet. We just don't know how to do it yet. We need to be realistic about that. And one of the biggest problems I think people think AI is kind of like magic, and it's not. It's just engineering techniques. And we need a big toolkit of engineering techniques. We have some already, but it'd be like saying, riffing on that other quote of mine that you used, it'd be like saying that because I know how to build a 2-story building, I know how to build a skyscraper. And, turns out to get from 2-story buildings to skyscrapers, you need to learn a bunch of new techniques. And people probably foresaw skyscrapers in Roman times, but they didn't have the steel to do it. And so, giving you another metaphor, we're sort of like in the Roman times, like, yeah, I can dream of that skyscraper, but I'm going to need to do some work yet. And steel is interesting because it's a combination of metal and carbon that is better than of iron and carbon that is better than its constituent parts for many purposes. I think that hybrid AI models that we need are like that. They're sort of better than their constituent parts. So we need the steel, and then maybe we can get on with the rest of it.
So the hybrid models that you speak about, or are they the neurosymbolic approach that you've spoken about?
Yeah, exactly. I mean, you could think neurosymbolic is what little we know about hybrids now is neurosymbolic, which is to say some aspects of neural networks, including their ability to learn from large amounts of data, and some aspects of symbolic systems that allow you to represent abstractions and to reason over those abstractions. And surely we need some of that. It could be that the details aren't quite like anything that we have now. And so maybe hybrid is even more abstract than neurosymbolic, but neurosymbolic is the most obvious way to build the hybrids that we want. It might turn out, for example, that the neuro part doesn't really work like the neural networks that we have now. So the neural networks we have right now are very inefficient. They're not very interpretable. Maybe we'll have a better way of doing that neural, quote, neural side. They're not even that neural, but that's another, I mean, that's like a name, but not they're not actually that much to do with brains. But something like that, I think, has to be right. You must be able to work with large amounts of data and integrate all kinds of idiosyncratic details and so forth. And you must be able to represent things abstractly and symbolically. I just don't see how to get to AI without at least doing that. On the other hand, I don't think that doing that by itself is enough. So I wrote an article called The Next Decade in AI in 2020 on Archive. And I argued that you need four things. Neurosymbolic is one of those things, like some way of bringing together these paradigms. But you also need large scale knowledge databases. You need to have reasoning, and you need to build cognitive models of the world as it evolves over time. You can think about the human brain. The human brain doesn't know what reality is, but it builds a guess about what reality is. That's what a cognitive model is. We need systems that build their best guess about the reality that's out there, reason over them with reference to a lot of knowledge they have using neurosymbolic techniques. When we can do all of that, then I think maybe we'll finally have decent AI.
And do you think we are on the path to actually meeting all those four requirements?
Not in the next 5 years. And the further out I look, the less I know. If the field insists on putting all of its talent towards large language models, we might get delayed. Because there's only so many people that are smart enough to think about these problems. There's only so many dollars that are going to be spent on them. And I think the current approach is the wrong one. I see some signs that some people recognize that, but I don't see enough for that. And so in the short term, I'm pessimistic. In the long term, I'm sure this will all, people are mostly looking in the wrong place, but science doesn't give up. Eventually, when it makes mistakes, they get corrected. And there's being a mistake right now, but the larger question is correct. And eventually it will sort out. Guessing the time of that is partly about money and partly about opportunity, partly about sociology. Like a lot of things go into that. Sometimes it takes enough failure at one approach. And so maybe we will have, another 10 years of people getting incremental improvements with large language models, but never getting to ones that are trustworthy and safe and so forth. And then somebody wakes up and says, okay, we really got to do something else.
In response to your critique of deep learning and the papers that you've published critiquing deep learning, Jan LeCun, he had said that the number of valuable recommendations ever made by you were actually zero. So what is your response?
This is my 2018 critique. He said it was mostly wrong. Yeah. So I said there were basically 10 problems. He said they were mostly wrong. And that's interesting also from the sociology of science, because everybody on Twitter jumped on me and so forth. The 10 things that I said were things like neural networks have trouble generalizing. They don't derive true abstractions. They're very greedy in terms of how much data that they require. They're not interpretable and so forth. Now everybody in the field recognizes that all of those things were true, right? It's 4 years later. It's not that much later, but everybody came around to recognize it. So, LeCun kind of bullied me, right? He didn't write a long critique saying, Marcus has 10 arguments. Let's look at the 10 one by one. And here's the counter. He just said he's mostly wrong. And it's like people following a political leader or something like that. They just, okay, well, Jan says it's wrong. It must be wrong. But nobody has ever shown that any of those 10, I think, was incorrect. And in fact, this is what people are working on now. People are trying to reduce the amount of data that these systems require. They're trying to get them to be more abstract, etc. So, having a famous person tell you that you're wrong doesn't mean you're actually wrong.
So, also speaking about deep learning, what made you start Geometric Intelligence?
I started that company because I was inspired by DeepMind, really, which is they showed that there was value in having good ideas, even if they weren't immediately commercial. So I wasn't born with, let's say, a business instinct. I've always been interested in the intellectual questions more, and they showed a way where there was real value to putting together a great team, thinking about interesting ideas. And Zubin Garamani and I had a really good idea about a new algorithm. And the team developed that algorithm, and we were only a little bit less than 2 years into it. And then a whole bunch of companies expressed interest in buying us. And ultimately Uber bought us. And then I think they did some interesting things with our technology, but I'm not really allowed to say what they were.
So again, I wanted to get back to the ethical issue of AI. So
Mhm.
Google, they recently fired Gabriel and Mitchell for their critique of large language models. So when it comes to the ethical or the privacy issues, what are your thoughts on it, and how can we actually build more responsible AI systems?
I mean, I guess part of what I'm saying is I don't think that large language models are the right technology for responsible and ethical AI. And that I don't think you can divorce questions of values and so forth from the underlying technology. Different technologies have different strengths. Large language models are very good at capturing statistical association, but they're not good at being responsible and ethical. They're just not a good technology from that. And as long as most of the investment is in that, we have a problem. And the privacy issues are a little bit separate. That's not a technology issue so much as a policy issue. But I don't think that we can solve the responsible in the sense of having a system behave ethically if we are using big statistical data dredging systems that don't have explicit values represented in them. I think that's a fantasy. Um, and so, as long as people keep looking at that streetlight, we have a problem.
So what if it's not data-driven models, then what would be the alternative to actually creating responsible AI models?
I mean, there's nothing wrong with having data or even large quantities of data, and other things being equal, large quantities are better than small. But we need systems that can take explicit English representations or something like English representations and reason according to them. So, the most famous thing in ethical AI is Asimov's laws. They're not perfect, but, don't harm humans is one of them. We need a technology where a system can propose an action, let's say a reply to a user, and evaluate, might this cause harm to a human? Like, we have to have that. And we're not even close. There's no system that can read a conversation, see this is the proposed reply, and say, this might cause trouble. We just don't have that. The best we have are like content filters that look for hateful language. And so they come up with things like, they'll say, they read the sentence, I am a black woman, and decide that that's harmful. And, when it's a declaration from a certain person's mouth as fact, and not from mine, it wouldn't be true if I said it. But these systems, they really don't know what they're doing. They're very, very naive in terms of how they evaluate hateful speech or misinformation. They just can't do it. What's better is you must be able to represent things explicitly, like be truthful, don't recommend harmful action. We just don't have the technology to do it. Minimally, it's going to have some symbolic component, because it is a symbolic expression to say, tell the truth or don't mislead or whatever. Like, we need a way to declare those things, which symbol systems kind of give us, and a way to reason over them. We don't really have it. We don't really know how to build it. I mean, I would be lying if I said I know exactly how to build it. I have intuitions about what might work better and carry us closer. But the strongest arguments are that what we're doing now ain't working. Like, that's just very clear, to me anyway. I think a lot of people are fantasizing that more data is going to solve it, but it's not. So we have to explore how we can get these things explicitly represented and valued, and how you build machines to do that. At the set of values, let's say, that the leaders of a community have, or something like that, most of them have been bad, right? I mean, so, historically, women have been accorded, essentially no rights. Slaves have been viewed as okay until, a couple hundred years ago. And so one doesn't really want to simply assume that, okay, in 2020, whatever, that we know the kind of royal way to ethical values, and we'll just capture what we've got now, because probably, even what we've got now is problematic, even if it's better than some of the stuff that preceded it. And so, in principle, but it's scary, we'd like machines to actually be able to reason about these things and even tell us, your moral values aren't consistent. You want to treat people as, treat people well, but you have this clause here that says that you can lock them up, and under certain circumstances. and take away all their rights, and that might actually not be consistent with your values. So it's a scary thought to allow machines into that conversation, but it's also a scary thought to freeze what we have now, knowing that all kinds of aspects are probably not great. There are other cases too that are like a little bit less black and white, but still significant. Like drunk driving was basically tolerated, I think, in most of the world for a large part of the history of driving, and it took a group called the Mothers Against Drunk Driving to really change the culture, to get people to recognize, hey, this is not really okay. And I'm glad that they did that. Deaths went down, and I think it's a good thing for society. So that's also kind of like an ethical progress. It's not as black and white as a law that outlaws slavery, or a proclamation that outlaws slavery, but it's still really important. And we would like machines to help us with that stuff and not to impede us with that kind of progress. Current systems, what they do is perpetuate prior data. They can't reason and say, well, these data reflect a historical bias that we need to correct. They just don't do that. That's not how they're built.
When it comes to you personally, what are some of your favorite books that have, shaped your thinking?
I would say Dawkins' Blind Watchmaker really helped me understand evolution was important. I loved Pinker's Language Instinct. I knew a lot of it because I had apprenticed under him. He was my thesis advisor. But for anybody who wasn't so lucky as to have him as a thesis advisor, I would highly recommend it. And even for me, it was wonderful. I was really inspired by Cosmos by Carl Sagan. It might feel a little dated now, but it was, the television series was amazing. The book was fantastic. Gödel Escher Bach by Doug Hofstadter is a fantastic book. I'm not sure anybody makes it through to the end. It's long, but such a lively mind connecting some of the basic questions about the world. There are all kinds of other books that are less germane to our conversation, like The Overstory that just won the Pulitzer Prize is fantastic novel. And there's any number of novelists that I love.
Thanks a lot, Gary. This is really interesting, and I myself, I learned a lot of new things. So thank you so much, and thanks a lot for taking out the time.
My pleasure. Bye-bye.